Alright, let's recap how we go about finding the gradient of a line joining 2 points. You can either use a graphical method, or I'm going to also show you an algebraic method. So let's have a look at the graphical method. We want the gradient joining these 2 points. So we need to draw up a set of axes, and let's put these 2 points on. 1, 5, 2, 4, 5, about there. You don't need to be particularly accurate, just so long as it is fairly in scale. There's 3, and we had 2, 4, 6, 8, 10, 11 would be about here. So let's put our point there. 3, 11. Remember, we go x first, then y. Alright, joining up our 2 points, here to here, as we've done in the past. Let's join them with a triangle so we can get our rise and our run. Alright, here's our triangle. Our x values have gone across from there to there, from 1 to 3, so we know our run is 2, 1, 2 spots. Our rise, we've gone from 5 on the y-axis up to 11 on the y-axis. So 5 up to 11, we've gone up 6 spots. Let's put that into our formula for gradient. We know our gradient is rise over run. Our rise is 6, our run is 2, so our gradient is 3. Now if we wanted to, we could do that all the time and it would always work. But you might want to shortcut this method, and you can't really be bothered drawing up an axis all the time and putting the lines on. Let's have a look at what we've actually done. We know the formula for gradient is rise over run, but let's break it down and see how we actually got that. How did we get this rise here of 6? We looked to see how we went from 5 up to 11. We worked out that the distance between 11 and 5 is 6. The difference between our two y values is 6. We can transfer that onto our equation as saying, if we just get the two y values and take them away from one another, that's going to tell us how far up the graph has gone. As we have done before, when we did our distance formula and when we did our midpoint formula, well, let's put a little subscript of 2 and 1 so we can differentiate between the two. So let's call this y from the second bracket, y from the first bracket. Then we know which numbers to put in where. For our run, we looked at how far along the x-axis we'd gone. We've gone from 1 to 3. The difference between 1 and 3 is 2 points. So to get that run, we can just get the two x values and take them away from one another. Again, let's put a subscript on them so that we can identify them, and we'll call this the x from the second bracket, this the x from the first bracket. So now that we've worked out this formula, we can use that all of the time instead of having to come over here and draw a graph. Let's see how it works. The formula for our gradient, assuming that we hadn't already drawn the graph, it says get the y from the second bracket. Here it is, so I'll put in 11. Take away the y from the first bracket. Here it is up here, it's 5. Divide that by the x from the second bracket, which is up here, 3. Take away the x from the first bracket over here, which is 1. 11 take 5 is 6, 3 take 1 is 2, 6 divided by 2 is 3. Our gradient is 3, just as we expected. So we're still doing the same thing, we're finding rise over run, but we're shortcutting by using this formula. We don't have to actually draw the graph. You could if you want to, it's always going to work, but this is a bit of a shortcut. Let's summarise all of our work that we've done on actually finding the equation of the line, not only the gradient, but the equation. And let's have a look at this example here. Here we've got a line, and I want to get the equation of this line. The first thing we're going to do is find the gradient. Now, you've done quite a few of these. The gradient we're going to find by doing our rise over run, our rise from 0 to 4, run 0 to 2, or we could do our y2 minus y1 and we will get our gradient. I might show you both methods. So the first thing I'm going to do is go rise over run. From the graph, my rise is actually a fall because I'm going down. So I'm going down 4 and I'm going across 2. My gradient is minus 2. If I wanted to do the algebraic method, my 2 points are 0, 4 and 2, 0. I've just read those from the graph. So let's call this x1, y1, x2, y2. My gradient formula is this. And we just put the values in. y2 is 0, take y1, which is 4, x2 is 2, x1 is 0, minus 4 over 2, minus 2, same answer. Once we've found our gradient, we need the other element of our equation, which is the y-intercept, and we just read that straight from the graph. So if you have a look at our graph here, we have a y-intercept up here where it cuts the y-axis is actually at 4. So the y-intercept is 4. Oops, I'll just write that properly. Y-intercept equals 4. Once we've got those two elements, that's all we need. We need to equate the gradient, we've got that. We need our y-intercept, we've got that. We put those two now into our equation. Instead of writing an m, we put down what the gradient actually is. And instead of writing the c, we write what value we have for our y-intercept. Very simply, let's finish that off then. Y equals the gradient. In both cases I got minus 2, so I'm just going to put that in there. Minus 2x. My y-intercept, I'm just going to get from here 4. So the equation of this line is y equals minus 2x plus 4. Summarising everything here with our gradient, you should remember that anything that slopes this way is a positive gradient. Anything that slopes down this way is a negative gradient. And then we had those two horizontal and vertical lines. A horizontal line has a 0 gradient, and a vertical line, we always say that the gradient is undefined. To find the gradient, there's two ways of doing it. Your rise over run you can get from the graph. The y2 minus 1 is our algebraic method. Both of them will work, and you should get the same answer no matter which way you do it. So that will allow you now to find the gradient of things and to go further, also finding the equation of lines.